Hello friends, in this video we shall discuss with respect to instrumentation and measurements, which is an important subject in order to crack UGC NTA exams as well as set exams. Already we have made a Fastrack revision video on electrical transducer, electronic transducer as well as mechanical transducer. If you have not gone through the video, links are given in the description. Also you can click on the I button. In this video we shall discuss each and every topic in detail. In order to explain this, I have taken the help of HS Kelsey textbook. Now, the total number of chapters are 20 in number, out of which 13 chapters are important. Rest of the things either you have studied in analog electronics, or you have studied in control systems, or you have studied in signals and systems. Say suppose if I am talking about filters, you have spoken in signals and systems, right? In the case of data transmission, you are covered in digital communication. Now, the chapter 1, that is qualities of measurement. Chapter 2, indicators and display devices. Here you will be having a PMMC, MI, EMMC, and you will be having LED display, LCD display. All those things you are going to study. In the case of ammeters, you are going to talk about AC ammeter as well as a DC ammeter, and how you're going to increase the range of an ammeter. In order to increase the range, the extra resistance you're going to connect either in series or parallel. So these things you're going to emphasize. Fourth chapter is based on voltmeters and multimeters. In the case of multimeters, 3.5 digit display is very important. Digital voltmeters is also important, and in the case of digital instruments, say suppose if I am speaking with respect to CRO, CRT, all these things are digital instruments. In the case of digital instruments, we are going to speak with respect to digital CROs, right, which is used for storing purpose also. And in the case of oscilloscope, signal generators are also referred as function generators, and wave analyzers and harmonic distortion. Measuring instruments and bridges are very important, and transducers is also very important. The first chapter is going to speak with respect to errors, accuracy, precision, nothing but the parameters it is going to discuss. Definitions are important. But if I am referring to chapter 10, 11 and 13, so these three chapters are very important. Let us move on to the first chapter. See, in the first chapter, that is quality of measurements, in this we are going to emphasize on performance characteristics as well as static characteristics. What do you mean? Like here they are going to emphasize on the definition. What do you mean by error? What do you mean by accuracy? What do you mean by guaranteed accuracy error? What do you mean by static error? What do you mean by dynamic error? And what do you mean by precision? What do you mean by resolution? What do you mean by full scale deflection? So these things they are going to ask. Especially in this chapter, error is defined as the true value minus measured value or desired value. But in rest of the cases, error is defined as a measured value minus true value. Error is defined as a measured value minus true value. Very important. And what are the types of static error you will be having? Error occurred. You are going to minimize the error. And then we are going to speak with respect to what are the sources of error. Even this is also very important. And the dynamic characteristics of error is very important. In the later part of the lecture, I am going to discuss what are the static characteristics of an error, what are the dynamic characteristics of an error. All these things I am going to discuss in the later part of the video. If I am coming to the second chapter, we are going to speak with respect to indicators, nothing but we are going to measure voltage and current with the help of voltmeter and an ammeter, basic instruments. Apart from that, we can make use of PMMC, MI, EMMC. What are the block diagram associated with it is also very important. You have to make a comparison, compare and contrast with respect to PMMC, MI, EMMC. These things are important. Apart from that, if I am speaking with respect to our display devices, you will be having a liquid crystal display, that is LCD, light emitting diode, that is LED. Nowadays you are having ultra LED and OLED, like the several versions are available. You refer to the previous year question paper, they have asked with respect to printers also. In the case of printer, so it's an output device, and the classification of printers, if I'm making use or if I'm telling, it is drum, dot matrix printer, laser jet printer, inkjet printer, and several versions are there. Main thing is talk about DPI. Main thing is talk about DPI. Right? They're going to talk about the hardware part. They're going to emphasize on the hardware part. Right? Very, very important. And application specific, if they're asking, you should be in a position to answer. In the case of ammeter, it is used to measure DC quantity as well as AC quantity. Refer to the previous year question paper, December 2019, Areton shunt or universal shunt. This question they have asked. Straight away definition kind of thing they have asked. Right? And how we are going to increase the range of an ammeter, how we are going to increase the range of an voltmeter, what is the way you are going to connect, how you are going to calibrate the ammeter and voltmeter is very, very important. If you are speaking with respect to the chapter 4, that is voltmeter and multimeters. In the case of voltmeter, again you're going to measure DC quantity as well as AC quantity. In the case of AC, you need a true value, or you need an RMS value, or you need a what kind of voltage you are expecting. In the case of AC measurements, that one you can able to measure. And you'll be having a multi-range voltmeter, true RMS voltmeter, shunt type ohmmeter is also available. And in the case of multimeter, see, in the case of A to D converter, which A to D converter is suitable for designing this multimeter or will be incorporated in the multimeter? It is a dual slope or integrating type. Very, very important. Dual slope or integrating type. Very, very important. In the case of digital voltmeters, what are the parameters that is associated with it? In the case of analog voltmeter, you are going to speak with respect to the full scale deflection, but here resolution we are going to emphasize. Sensitivity, selectivity, important. In the case of digital voltmeter design, especially we are getting into 3.5 digit display, but in the exam they can ask 4.5 digit display also, 2.5 digit display also. What is that half signifies? What is the change in the range? All these things we are going to discuss in the chapter 5. If I am speaking with respect to the chapter 6, we are going to talk about digital instruments. See, voltmeter, ammeter, multimeter, each and everything are available in analog domain, or analog instruments are available. But for simplicity point of view and for easiness point of view, we are going to convert an A to D converter, and that will be a digital instrument. In the case of digital multimeter, digital frequency meter, decade counter, refer to the previous year question paper 2024, they have asked. Multiplexer connected with a counter, this question they have asked. Digital tachometer, this tachometer we are going to talk in a power electronics subject in order to measure the speed of a wheel or a speed of a motor. In the case of digital phase measurement, see, 2 wattmeter method is there. You can able to measure the power that is being consumed. Similarly, what is the phase? What is the phase? Digital phase meter is used in order to measure the phase also. Digital capacitance meter is also available, right? And in the case of oscilloscope, refer to the previous year question papers. Like 5 years down the line, you just go through, they have asked with the block diagram, arrange from left to right. Such a simple question they were asking, but nowadays they are not at all emphasizing. And what are the parameters and specification that is associated with the oscilloscope? Block diagram of cathode ray tube and cathode ray oscilloscope. Storage option, if it is there, means it is a storage oscilloscope, right? Especially available in digital CROs. Probes you are going to use. In that probe, can you attenuate the signal is an option, right? That and all we are going to discuss. Lissajous figure is very, very important in the case of CRTs, right? Many specifications are there. All those things they have asked in the exam. We have to go through it. So these things will be discussed in chapter 7. In chapter 10, that is measuring instruments, stroboscope, phase meter, Q meter we have studied even in network analysis also. What is the quality of a coil? Minimum you should have 5 in the case of series resonance circuit. And in the case of LCR bridge, Megger instrument is very important. For measurement of high resistance, you are going to make use of mega ohm bridge or Megger instrument. Like this you will be having. AC bridges and DC bridges. Bridges topic is very important. Refer to the previous year question paper. Minimum one question is available from bridges. AC bridges, resistance measurement. Is it a low resistance? Is it a medium resistance, or is it an high resistance? In the case of low resistance, how many terminals are there? 4 terminals you will be having. Sometimes 3 terminals you will be having, not 2. Like the resistance will be having 4 terminals. In the case of a low resistance measurement, you are going to make use of Kelvin's double bridge, as well as you can make use of potentiometers also. In the case of medium measurement, we can go for voltmeter ammeter method, substitution method, Wheatstone bridge method. Also you can go with the ohm meter method. In the case of very high resistance, you can go for loss of charge method, Megger instrument method, direct deflection method, and mega ohm bridge. So these things are these are the bridges which will be used for measurement of high resistance. Next, inductance. In order to measure, you can make use of Maxwell's inductance capacitance bridge, Hayes bridge, Owens bridge, as well as Anderson bridge. In this, they will be asking with respect to the quality of the coil. In the case of Maxwell's bridge, it is a medium quality, right? In the case of Hayes bridge, quality is high, right? Like this you are going to emphasize. And in the case of capacitance, epsilon you can measure, right? Depletion width you can able to measure. Like this you will be having Shorty's bridge, de-Shorty's bridge, sharing bridge. In the sharing bridge you can calculate each and everything. Next, if I am getting into the 13th chapter, which is very important, that is the transducer. We have already made a detailed revision video on transducer. If you have not yet gone through the video, links are in the description. You can go through it. Here, see, transducer definition they will be asking. Conversion of non-electrical quantity to electrical quantity you are going to perform with the help of transducer. In order to do this process, if you are making use of only the resistor network, it is referred as what? Resistive transducer. In order to convert this, if you are going to make use of inductive network, then it is inductive transducer. You are going to make use of capacitance, then it is capacitive transducer. Very important. In this, strain gauges, thermistor, LVDT, these topics are very important. When I start taking this transducer, minimum I will be taking 5 to 6 hours of lecture. That is very necessary, right? In order to deal this 13th chapter. Most of the questions will be from this transducer as well as from bridges. Very important. Now let us get into the first chapter. In the static characteristics, we should know what do you mean by an accuracy, a resolution, precision, expected value, error, and sensitivity. We shall discuss one by one. In the case of accuracy, it is the degree of exactness of the closeness of a measurement compared to the expected value or the desired value. Say suppose the total number of marks they are going to conduct for 100. Out of 100, how much I am scoring? How much I am scoring? Say suppose 95. 95% accuracy. Or say suppose, if I want to give one more example, what is the value of pi? You can tell it is 22/7. One more person can tell 3.15. I can tell 3.1415. So like this, accuracy is defined. How close is the measured value with respect to the true value? This is how accuracy is defined. A resolution, the smallest change in the measured variable to which an instrument will respond. What is that small amount of input you are going to provide such that the instrument is taking the reading or it is coming out with a value. Precision, the measure of the consistency or repeatability of measurements. So this is how precision is defined. Say suppose now I am measuring, I got 12 volts. Again, if I am measuring 12 volts, again if I am measuring without changing the circuit, how many times I can, if I am measuring, I should get a same value only. So that's how precision is defined. Expected value, it is the probable value that is close to the true value only. And error is a deviation of the true value from the desired value. True value from the desired value. Very, very important. Very, very important, right? So it is the deviation of the true value from the measured value or the desired value, right? Definition, one textbook, one way they are going to define. One textbook, one way they are going to define, right? In this, sometimes they will be speaking with respect to true value minus measured value. Some other times they will be they will be telling it as a measured value minus true value. But here it is the deviation. How much it is deviated? They are asking. That's it, right? So error can be positive, negative, or it can be even zero also. Sensitivity, the ratio of change in the output response of the instrument to the changes with respect to the input. Very, very important. This is how the sensitivity is defined. Now, errors, if I am speaking, you will be having three variants of error. One is a gross error, systematic error, and a random error. Gross error is nothing but what? Human making mistake. While tabulating, the person is going to make a mistake. While copying, he is going to make a mistake. While writing also, many times I have made a mistake. Then that is what? A gross error. Systematic error means what? Look at the things. Shortcomings of an instrument such as worn parts, aging, or effects. As my age proceeds, my thinking will get decreased. Similarly, the instrument is not going to respond in a proper way. Example, say suppose a spring is there in the instrument. Upon elongation and contraction, expansion and compression, its stiffness it is going to reduce, such that the output is going to get deviated. And the random error or the residual error is nothing but the accumulation of the smaller error becoming huge one. Small error, it is becoming a huge one. One example I will give you. In the case of oscillators, say suppose Hartley oscillator you consider, noise at the output stage will get into input, amplify, come back, amplify, come back, such that this process will be continued up to where A beta equals to 1. Nothing but what? Barkhausen criteria, right? So this process is continued till A beta equals to 1, nothing but Barkhausen criteria. So the noise is very, very important. We have to discuss. Next, in the case of systematic error, you will be having again three variants. The first one is instrumental error, environmental error, and observational error. As the name indicates, there is a problem with respect to an instrument itself, then that is defined as what? Instrumental error. Environmental things are making mistake. Right now I am recording the lecture, aeroplane sound, bus sound, lorry sound, this is all what? Environmental distortion. Similarly, in the measurement also, electric field can be an error. Magnetic field, if it is getting induced, then it is also an error. And observational error, see, say suppose now I am looking at the wall clock, the time is around like 10:50. If I am seeing at one angle, right side, if I am going and seeing at the time, that the time will be slightly deviated. Assume that the time is 12 o'clock. Right side you move and then you see, then the time will be how much? 11:58. Left side you go and see 12:02. So these things are nothing but what? Observational error. In the case of instrumental error, manufacturing defect, at the time of manufacturing only defect is there. See, person getting hereditary, it's a manufacturing defect. It is a manufacturing defect, right? Hereditary you will be getting, that's a manufacturing defect, right? Aging, because of prolonged usage. Because of prolonged usage, the instrument performance is getting degraded. Loading effect, I have told the lorry driver that the maximum weight you should put is 5 ton. Because of his greediness, what he will be, how much he will be loading is 10 tons he will be loading. So the lorry manufacturer, he has to design or he has to consider the factor of safety also. 10 tons also it will move, 10 tons also it will move, right? Loading effect. Misuse of instrument means, say suppose I want to measure a current, you have connected a voltmeter. Say suppose I want to measure a voltage, you have connected an ammeter. This is what misuse of an instrument. This is what misuse of an instrument. Similarly, in the case of environmental error, electric field, magnetic field and temperature are very, very important. So these are all what distortion. These are all what distortion. Very, very important. Till now we have talked about the definition of error, types of error. Now let us talk about the sources of error. Insufficient knowledge of process parameters and design condition. Error occurs. See, in one example I can tell you, see, source terminal is there, drain terminal is there. Here adjacent to this you will be having one more set of transistors. You have not laid enough field oxide. This thick oxide you have not laid more. At that time there will be an interference from one transistor to another transistor. One transistor to another transistor, right? Next, poor design. This may be one of the issue. Change in process parameters or irregularities or upsets or poor maintenance. This poor maintenance is also an important thing. Poor maintenance is nothing but what? You are not performed calibration. That's it. Errors caused by person operating the instrument or equipment. Not knowing how to use. Gone. Certain designs limitation is also one of the issue. Certain design limitation is one of the issue in the case of sources of error. Next, in the dynamic characteristics of an instrument, if I am speaking, you will be having 4 variants. 4 things we have to discuss. Nothing but how fast your system is responding to the changes with respect to input. That is referred as the speed of response. Fidelity, it is the degree to which an instrument indicates the changes in the measured value without dynamic error or faithful reproduction. Nothing but, see, say suppose if I have given a square wave as an input, in the case of op-amp you will be getting a slope kind of thing. Faithful output you didn't get. Right? How much faithful you are going to get is a fidelity. Like this, if I am getting, means this circuit is best. Okay. Next, lag is similar to the speed of response. It is the retardation or delay in the response of the instrument to changes in the measured value. Hold time and setup time. In the case of digital electronics, you remember those 2 concepts enough. See, in the case of networks, the lag is because of resistance and charging and discharging curve in the case of inductance and capacitance. Because each and every instrument requires some time in order to respond. And in case of dynamic error, it is the difference between the true value of the quantity that is changing with the time and the value indicated by the instrument, provided there should be no static error. Very, very important. So these things are dynamic characteristics. I have given the list of questions. You please go through it. If you are not in a position to answer, you can message me on WhatsApp, or you can discuss even on our Telegram group. Please go through it. And I have given the list of MCQs also. Pause the video and you try to answer these things. If you are unable to, then you can feel free to comment in the comment section. So friends, in the first part of the video, we have talked about the characteristics of an instrument. So what do you mean by accuracy? What do you mean by precision? What do you mean by resolution, full scale deflection? Each and everything we have tried to analyze. What do you mean by an error? What are the sources of error? What are the types of error? How you are going to classify the error? How you are going to minimize the error? Each and everything we have discussed in the first part of the video. In the next part of the video, we shall discuss with respect to the basic comparison or full comparison with respect to PMMC, MI and EMMC. Also, we are going to discuss with respect to LCD display and LED display. So first chapter, if you have thoroughly understood, please give it a big thumbs up. Also share this video with your friends and don't forget to subscribe to my channel Craving Gyan. All the best for exams. Thank you. For test series, make use of craving gyan.com.